So welcome to the fringe growing contest that is Advent of Code this year. There are reasons, but yeah, anyway, day 13, distress signal. And I'm not talking about this series of videos. That is the name of today's challenge. We've got a list of pairs of lists of integers, kind of. They can be recursive, but they're all in pairs, and the story goes that some of these are in the right order and some of these are in the wrong order. It doesn't tell us what the right order is, just that we need to work out how many, or rather the indices of the indices of the pairs that are out of order. And there are some rules for us to use to determine the order, or rather to determine whether the order is correct. There are a few rules hidden in here, and there's an example as well. I'm going to shift to my Scala drawer. Well, actually, just so you can see the real input, because it's not so long, but it's, longish. And in terms of the recursiveness of the lists, it doesn't look like we're going to go over the stack size here. So that's worth noting, because if we were likely to recurse a lot, then that would change how we needed to approach the solution, or at least it would restrict our options a bit. So I'm going to articulate this problem in a moment, but just first, I'm going to articulate some adjustments to this challenge that I've taken on. To do each step in however much planning I want, but only half an hour's coding. And it's getting a bit challenging and a little bit. I found myself running over and then not sort of pressure being off. So I'm going to change the rules a little bit. So this is an hour clock, and stolen this from GeoWizard straight line challenge. So if it's done in 15 minutes, that's going to be a platinum step. 30 minutes, of course, is going to be gold. 45 minutes, or within 45 minutes, is going to be silver. And if I can copy and paste, then fine. And then 60 minutes, within 60 minutes is going to be bronze. And then beyond that, it's going to be lead. And let me just decide whether these are inclusive. Well, if we get to the 1500, then that's, if it's done by the time that we see 1501, then that's within the time. So it's really, I've got 15 minutes with which to do this. So we'll see that today, and that should keep a little bit of the pressure to improve on. I still think all these should be doable within 30 minutes. It's not, in principle, the exact precise code that needs to be written is not very long for any of these so far. And so in principle, if I was just typing, then it would be totally possible to do it. Of course, it's a puzzle, so there's that part to it, but in principle, it's doable within 30 minutes each time. So I should keep challenging myself to that. Another thing that I'm just going to change in my process to make this more realistic, more viable, I think, is a couple of steps ago, we looked at this diagram, and this is a diagram of roughly how you might break up a program to solve a complex problem, given that there is, let's say this is my brain, and the size of these circles is like the size of the amount of stuff I have to keep in my brain at once in order to solve it. So if we try and solve it in one big, let's say this is the sum of all of these circles, of course, it's going to not fit in my mental limits, and I'm going to get overwhelmed, anxious, unable to actually think through the problem that I'm looking at. So the idea in most human programming is to segment the problem into pieces that are small enough to fit inside one's head, and then treat these pieces in isolation, and then go through a process of synthesis to draw these pieces together into solving the complete problem. And in day-to-day programming, this works quite well. And the way I've been doing this is breaking it down in the planning stage into these pieces, then writing each piece, and then sort of building it together either at the end or in intermediary stages. Now, the problem with this approach for me at the moment is that if I start at this point, I've then sort of got so much to do by that point that I neglect verifying the correctness of this part. And so later, when it comes to synthesize, I've got a big swath of mistakes that I've made that I need to correct. And because I'm not thinking about these small pieces, actually the useful part of the segmentation in this step is gone, because I'm not debugging piece by piece. I'm not verifying piece by piece. I'm just writing piece by piece. And then all the mistakes I handle as one big, mess of mistakes at the end. And this isn't working. It doesn't really, well, it doesn't work. So so I'm going to change my approach a little bit and veer away from my day-to-day style. And instead of breaking things down and then looking at the small pieces to write those and putting them together, I'm going to go a different approach. So I'm going to, I suppose, do a breadth-first approach. And I'm going to visualize the program a little bit like this. So we're going to start off with, let's say, something like this, maybe probably half of this in reality. And this is going to, when this is run, this is going to change the state of the program to something else. So in fact, if you visualize the square as the, okay, this gets slightly confusing. The square is the state. let me just rethink this entirely. Let me get this off here. Yeah. So the job of a program, in particular these programs, is to convert, or you can imagine the job of this program is converting one set of state to another set of state. So one set of variables memory into a useful set of memory, the problem memory into the solution memory. And so by visualizing, by looking at the program like this, we have a different approach that we can take. If we build sort of top end first and have a good sense for how the state should change. So let's say this is, A and B. Then if we can run this and then visualize the change in the terminal, well, then we will have more feedback on whether it's right or not. And we can gradually build out the little pieces of the program, verifying at each point that the state is correct. So this might seem a little bit theoretical at this point, but you'll see it in action a little bit today. It's probably, and then the benefit of this is that I get the correctness feedback throughout. We're getting to see things running more. And if things do get a bit spicy on the time side, I can adjust, whereas you can't really adjust in the integration stage because it's all done. Whereas you could potentially take a few shortcuts in the kind of small pieces if you are getting kind of good feedback on this. So this is going to involve kind of two big changes. First is start with the main loop. Second is visualize program state. And you'll see these work out today. I think that storing all the meaningful program state in a pragmatic way inside one class has actually been quite useful. And I'm going to add a visualization method to that class so that we can see the program run and possibly step through it as well. So you'll see that in action today. Anyway, so that's my sort of process chat. Let's look at the problem. So we've got a few different examples here. I've labeled them A through H. On the right, this is the examples we're given. And the task is to work out whether they are in the right order or the wrong order according to these rules. So these are the rules. I've sort of slightly paraphrased them from the Advent of Code challenge description. So rule 1 is if both values are integers, the left integer should be lower. Rule 2 is if both values are lists, compare item by item. Rule 3 is if both values are lists, the left list should be shorter. And rule 4, if exactly one value is an integer, convert the integer to a list. So kind of, in a sense, we could probably reorder these, but I'm not going to because I don't want to give myself that job right now. So let's look at this. I'm going to use this little square here to walk through each example. I've chosen A, B, G, and H, not all of them, just for time. So if we run through item by item, so we've got a list here, we compare item by rule 2. By rule 1, if both values are integers, the left integer should be lower, or I think equal. So I'll change that. So equal meaning lower or equal. So this one's good, this one's good, this one is good because 3 is lower than 5. This one's good and this one's good, in which case this one is correct. Moving on to this one. So we've got a list here. We go into the list, we go into the list again, all good, into the out of the list, into the list. Okay, so this list, by rule 3, if both values are lists, the left list should be shorter, which it is not. So this one is, no, that's not right. Let me look at this again. So this one's supposed to be in the right order. Oh yeah, no, I get it. Or do I? No, I've got a mistake here somewhere. 1, 2, 3, 4. The left list runs out of items first. The inputs are in the right order. Okay, so actually, let me rethink this. Yeah, okay. No, I see what's happened. Yeah, so I actually did this one. Yeah. So yeah. So this is the actual input. Okay, let's try that again. So you can see that here. I just messed up the example because I tried this out before. So list, okay, integers good. This is good. This one means that because we're comparing a list and an integer, we need to convert this into a list. And then we go down this one, and we're looking at 2 is less than 4, so that's good. And that means that it's correct. So we stop moving there. So kind of one thing is there's a difference between correct, incorrect, and continue evaluating. So that's worth noting. And so by this, so this is correct by rule 1, but this rule is now, see, I put an asterisk here because I wasn't sure if I'd gotten this right. It says if the left list runs out of items, what does it say? If the left list runs out of items first, the inputs are in the right order. So actually, if both values are lists, the left list should end, no, the left list should end first. So, but if rule 1 matches first, then we don't get to rule 3. Okay, so that's fine. Just a slight enhancement. This one's kind of interesting, so I put this one in. So list, we move into it. List, we move into it. Now, the right item has run out of items first. before the left item, because the left item's, even though it's an empty list, it's still an item. So actually this is incorrect by rule 3. And this one I just put in because it seemed long and interesting. So move into the list. This is good. Continue into the list, continue into the list, continue into the list, continue into the list, continue, continue. Okay, left is higher. Incorrect by rule 2, no, 1. So we get to this set of rules broadly right. I'm sure the coding out of it will be slightly different, but that's roughly what it's about. So I hate saying this again. I don't know why I keep torturing myself by saying this, but it doesn't seem so hard. There's nothing immensely impossible in this. So either I'm wrong and I'm about to step into a trap, or step 2 is going to be challenging. So anyway, I've planned out my state. So I'm going to have a list of the lines, the full left and right, the left-right segments that we're currently looking at, the left indices and the right indices. I'm just going to keep track of those so I can visualize them out, and the order so the correct order of whether the order is correct, rather. And I think I'm not going to type hint some of these things because I wasn't 100% sure how you type hint recursive data structures, and I don't want to spend any time on it. My plan of action is to munge the data into a big list in some way. I think I'm going to use JSON lines for that on reflection. I think that'll be slightly easier to get started with. I'm going to write the state and visualize it out. I'm going to iterate over the pairs, and then I'm going to write a recursive comparison function. And I need to actually remember to track the indices of the wrong ones. No, the right ones. Next, indices of right pairs. And in this case, it's 13. Okay. I'm just going to spend a moment just thinking about my visualization. So I'm going to have I think left full. No, let me have the short ones at the top. Left seg, right seg. Order correct. I want to have these same length. Order correct. Left full, right full. And we'll have the lines, I think, maybe somewhere just at first, maybe. I might start off with the lines. So I might change the state as we go through, change the visualization as we go through. And I'm also going to have the indices here as well. And yeah, great. And then all the normal logging as well. I'm going to try to do the logging in the same format, maybe. I won't get fancy with the logging. I'm just going to see if I can get it right first, and then I might add logging in the same format if I need to debug. So yeah, okay. So this gets us to the right point. And yeah, I think we're good to go. So let me switch to VS Code. Get my trial input. Do I have an extension for this? No. Yeah, I'll just read it as anyway. Okay. And the input. Okay. I think we are good to get started. Okay. Let me reset this. You'll be able to see this timer in the toolbar now. I changed that because it's annoying doing the phone. Or, not that. Oh yeah, it's got timer. Yeah, reset timer. Okay, and do this, reset timer. Okay, great. Okay. This doesn't work. Yeah, okay, great. I'm going to get the state into the right format for this. Uh, hmm. Right. Didn't think this through. Okay. Okay. Hmm. Okay. Hmm. Is this the problem? Does it not like blank lines? That's correct. Um, I can handle that. Okay. And I might actually change this to be pairs, just because that'll be easier. Okay, great. Perfect. Okay, that's that bit done. Okay, we're getting more interactive now. So why are we starting off with that? Oh, we're not visualizing yet. We're not calling this. Okay, great. So we're going step by step. Okay, are we going through one by one? Yes, we are. Great. Okay. All right, so rules. We're going to go over each item. To get a segment. Okay, and the left list should end first always. So that's good. Actually, we want to have these be start off. Okay, firstly, we want to iterate over these. If Dictionary. I don't need you now. Okay. If state left seg is greater than or equal to, yeah, what's the rule? Left integer should be less than or equal. Return, well, return anyway, return something. Doesn't really matter what, because we're not going to set the state. Else we should say state order correct is false and return false. And so in this case, we should say if state order correct, just return. Slide this down. So we get to 1, and then we fail when we'll fail at some point. Are we just, maybe we should check. This is on line 59. Oh, obviously, very silly. The same problem. Left sex1, right sex1. Well, that's true. But we should be getting to this. Why aren't we getting to this? So this is true. So we're getting in here, right? We're definitely getting in there, which means we should be returning at this point. Which we are. So we're returning here. What's the index here? So we get to 1. Right. Okay. Right. Okay. So we need to store the previous right segment. Yeah, you wouldn't run into this if you weren't doing this silly nonsense that I've set up for myself. Okay. Right. So autocorrect still none. Right. Okay. So if in this case, this should actually indicate true. So that's correct. Okay, less okay, so 9 and 876. This one should be false, actually. And so here, okay, so we need to have this will now be an exclusive OR, because we've already done that and, right? So in which case we should have right, okay, I see. So this one should indicate this. This one should indicate if they're equal. And this one should just return. Why is that correct? Oh yeah, I need to reset it every time. That's fine. can't believe I'm going to lose this one as well. These should be getting converted, right? Both lists. Well, they should be both lists. So we are comparing 1 with 1 here, and then we're returning so comparing 1 with 1, which we do correctly, it returns none. It doesn't return here, and then it sets the right segment to the previous right segment, which I don't know if that's necessary actually. Well, it is here. Okay, let's do this differently. So if they're both integers, if the left is an integer, this one should be matching this time. And it is matching. It's just, oh, okay, fine. I need to make it return. Okay, so if, are we getting the right outputs here? Let me check. Let's get this, and then, okay, true, false, none. That's not good. So this one, left runs out first, so that's correct. So if at the end of this, if um, if length of the right seg is less than length of the left seg, then the order is correct, and we return. If we get to this point, and if index is greater than the length, greater than or equal to the length of right seg, then order is correct and we should return. Order is incorrect and we should return. Okay, let's try this. Correct. Okay, none. So the length of it's the other way around. If the length of the left segment is lower, yeah, so true. False. It should be false. Oh yeah, okay, that's what I got wrong. So we need to check. So if we get through to a point where the left has run, okay, so then if state right seg on index is 1, so if the length of right seg is still greater than final index, then return, then the order is correct. Horrible. Where's my indent wrong? Oh yeah, true, false, true. This next one should be false, and is. This next one should be right. This one's true. False, false. Okay, and that's us done. So now we want to store let's let this keep running. Still got a silver. Okay. Indices. Some state. Well, okay, let's just do this in the viz. $13. Okay, great. Let's get rid of all the sleeps. Okay, let's get rid of this. That, okay. Now the input, the proper input. $5,003. Let's try that. Okay, so that was 4104. Roughly. Okay, so silver. Let's take a look at part 2. Now you just need to put all the packets in the right order, disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. Using the same rules as before, organize all packets, the ones in your list of received packets, as well as the 2 divider packets, into the correct order. for the example above, the result of putting the packets in the correct order is these. So we should flip them, right? Pause this for a moment. Okay, back. So I don't get this at all. What puts them in the correct order? Afterwards, locate the divider packets. To find the decoder key for this distress signal, you need to determine the indices of the two divider packets and multiply them together. The first packet at index 1, the second packet at index 2, and so on. In this example, the divider packets are 10th and 14th, so the decoder key is 140. So is it that we just need to kind of work out what the order is? So we've got a pairwise comparison function, and we need to work out what order they go in based just on that, maybe? How many lines do we have in our input? So 300, which means the brute force way to do this, given that we don't know that any of the packets are in the right order, is to try every combination. Every combination of 300 packets, which is going to be a comically large number, probably. I don't remember my combinations from A-level. Okay, fine. Well, there are a few principles we can apply. Okay, I'm back. And basically, I realized that I was being very silly about everything. I don't need to create, you probably won't even see the bit that I was being silly about. Basically, I went in this whole palaver where I basically worked out, these look kind of like alphabetically ordered, almost. So if we come up with some sort of sort key for each one, then we might, that might make the problem solvable. But then I realized to implement a sort, you only need less, greater than, or equal to. So, we've got enough to sort already because we can see whether the order is correct, in which case the sort is ascending, or incorrect, in which case it's descending, or equal. I don't know what happens if you get equal. I might just see if I can find that out. But basically, we've got everything necessary. So I need to work out sort with a function in Python. Sort with a comparator Python. No, I don't want to upvote it. So, yeah. So Rich comparisons, gosh. Okay, I don't know how it does this, but I don't need to know, I hope. So in principle, I've got everything I need. So action plan wise, this was my old plan. My new plan is sort using sorted key, and what is it? To key, and hope that the sorting will actually work. I want to actually, I guess, add in our special structures, which are 6 and 2. And 2, sort using sorted, and then I want to get index of special structures. And maybe figure out what happens when we're equal, which I think won't happen. So it shouldn't matter, but maybe it will. So let's get started on this. This, I don't know why it's called cat, but it is. So let me roll this back to where it was before I messed around with everything. Would have been so much quicker to copy paste it, wouldn't it? No. Okay. Okay. Great. So let's get started. Oh gosh. Okay, once more. Reset timer. Okay, let's paste this in here. And we're going to go with part 2 this time. Okay. Do I have any sleeps in here? No. Fine. So my plan is, so we're going to add in our special structures. Okay, state as append. And this one, which is the right ones, right? Yes. Okay. And then I want to sort and I want to there we go. And I want a version of this which is if compare pair as comparator. So and I want to get can't really pass in the state, can I? Yeah, I can actually. And I want to essentially reproduce this. So if so if x is less than y, that's the correct order. So we should return -1. If state order correct is false, then we should return 1, else great. Okay, and so we've got this, and we can say pair as comparator, and we can pass in the state. And then we also kind of want to visualize it here. Okay. And actually, I kind of want to flatten these. Allegedly, this flattens things. 94. All right. So those aren't getting called because I'm not actually calling this properly. Okay. Okay, so how do we do against our correct output? Not right. Not right. Not right. So the first three are right. Let's check them, shall we? Then these should be here. Then this one, these two. So that's, okay. Okay. So they're kind of right, but the ones are in the wrong order. We've got all the ones, then the twos, then the threes, fours, nines. So some of it's right, but some of it's wrong. We're getting weird. This is odd. We're getting the right things here. But then in here, oh, sorry. Let's try and just work this up maybe. So this is right. Okay. If the left one runs out, okay, compare these two. Okay, so this one would indicate that they're in the two is smaller. So they're in the right order, right order, right order. The lower integer should come first. So that's right. If both values are integers, are fine. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the items are in the right order. Sorting 6 and 2. Sorting 2 and yeah, okay. 1 to 1 and 2 with 1. So this one should indeed come after. Yeah. Yes. Yes. So these are right. Okay, let's add in a bit more complexity. Okay, fine. Pairs then. Okay, so I may be wrong in one of my assumptions that we can just sort these. Okay, so 1, 4, 1, 2, 3, 4. Well, this should, okay, so here's an interesting one. Iterating over the lists, this one and one, comparing one with one. And so this returns so we can narrow down to this, maybe this pathological example. Or not. I don't see the same problem there. 1, 4, 1, 2, 3, 4. Oh, sorry. 1, 4, 1, 1, 1, 1. So it's 1, 4 and 1. 1, 4, 1, 2, 3, 4. 1, 4, 1, 2, 3, 4. 1 and 1, comparing 1 with 1. Yeah, this shouldn't terminate at this point. So if these are equal, it should return and continue and continue. Stay autocorrect is not none. Is not none, return. Okay, so this, can we debug this? Whatever. Whatever. I'm not fiddling around with the debugger now. Oh, should return. And when it's done with that, when it's done going through a list, it should get to here, get to here. Okay, that's fine. Let's try this out. Okay, so we go 1, 3, right. Okay, that's not right, is it? So we shouldn't be getting to here. And it is because the length of the right segment is greater than the final index, which is 0. Right, let's try that again. Okay, so equality is not handled. What do we get here? Something even more wrong. But is it closer? Kinda. It's different. Let's try this case. So we saw 3, and yeah, so this should indeed be after. Let me yeah, those are not the same. So this one, converting 3 to 3. Okay, iterating with it, converting 3 to 3. Over this 3. So these should not be equal. In this case, this should be matching. So the length of the right segment is 1, and this is 1. And this is this is 1. Because yeah, so it's very annoying. It's very annoying. What have I gotten wrong here? This case is problematic. Okay, so what I'm trying to look for is, are there numbers in the right segment that are after the last index we checked, which should start off being 0. And if there are, then if final index is 0, then this being 1 should trigger this. But that undoes the work I just did. Which was this quad here. Which should be so that's in the right order. Comparing these two, we're comparing 1 with 1, and then we don't move on. We don't move on. That's the problem. And we're matching this. Why have we ended up with final index 0? Oh yeah, because this needs to be -1, I think. All right, let's try it with this again. Okay, where are we at? Still not the right place. But possibly these 6 are in the right place. 2 and 14. Could these all just be equal? Uh, it's worth a try. It's very dubious, isn't it? I mean, are they all in the right order at this point? Let's check it with part 1. Which now sort of needs some correction anyway. So maybe I'll just copy this over. Okay, so let's try this. But are they all right? 45, that would be the result of all of them being right, I think. Yeah, okay. They're all right. It's just that it's different to the example. Okay, so 10th and 14th, 140, fine. So in that case, we can get out the index of the Why doesn't that work? Oh, uh, it's the wrong type. Okay, let's try part 1. 9 and 13. Okay, well, that's +1 to that. Okay, let's try it with the real one. See if we get anywhere near right. 2280. Let's try it. That's right. Wow. Well, what an adventure today was. Yeah, so maybe not super inspiring today. Some pretty horrible code. Definitely could have done this better with a bit more planning up front. Probably the first time planning really hasn't been good enough in the proper planning. I could have done a proper chart out for this, and that would have really helped. The part 2 was sort of challenging to know what to do, and I think I over-indexed on the solution being exactly right. Didn't really, yeah, bit of sloppy thinking there. But not too far after 30 minutes. I'll update the description with what that is. Yeah. More fun tomorrow.